Hello everyone. Welcome to another video in the Cloud Practitioner series. In this video, I'll be talking about Amazon EC2 or Elastic Compute Cloud. It's one of the AWS oldest and most important services, and it basically lets you run servers in the cloud. These are the topics we'll be discussing in this video. And at its core, EC2 provides virtual services in the cloud, virtual servers. You can think of it as renting a computer from Amazon that runs in their data centers. It's on demand, meaning you can launch a server when you need it and shut it down when you don't. It's also scalable. If you need more CPU or memory, you can pick a different instance type or add more servers. You are not restricted to one operating system as well. EC2 supports Windows, Linux, and custom OS images. Another important point is EC2 is global. You can launch instances in data centers across the world, close to your users. And finally, it's very cost efficient since it follows a pay-as-you-go model. You only pay for the time your instance is running. Let's break down the main components of EC2. An instance is simply the virtual server you create. To launch one, you need an AMI, which acts as a template. It defines the OS and any pre-installed software. AWS provides many AMIs, but you can also create your own. AWS offers different instance types grouped into families such as general purpose, compute optimized, or GPU based. Each one is suited for a different type of workload. EC2 instances need storage. EBS volumes are like virtual hard drives that persist even if you stop or terminate your instance. On the other hand, instance store volumes are physically attached disks that are very fast but temporary. You lose data if the instance stops. Key pairs are how you securely log in. Instead of a password, you use cryptographic keys. And finally, security groups are like a firewall. They control inbound and outbound network traffic at the instance level. Moving on, AWS offers a huge variety of instance families to fit different needs. General purpose balances CPU, memory, and networking. These are great for web servers and everyday workloads. Compute optimized gives you more processing power for CPU intensive tasks like batch processing or gaming servers. Memory optimized are best when you need huge amounts of RAM, such as databases, caching, or big data analysis. Storage optimized are designed for workloads that need extremely fast read-write to disk, like analytics or log processing. Accelerated computing includes GPU instances for machine learning, AI, and rendering. And there's a special category in burstable. The special category is burstable instances, such as T-series. They provide baseline CPU performance but also allow bursts when needed, which makes them cost-effective for variable workloads. AWS keeps updating these families, so newer generations are usually faster and cost-efficient than older ones. EC2 works with multiple storage options. EBS, which we talked about before, volumes are most common. They are persistent, meaning data survives instant shutdowns. You can resize them and take snapshots for backup. Instant store gives you very fast disk storage, but it's temporary. If the instance stops, data is lost. It's useful for caches or temporary data. And similarly, EFS is a file system you can mount across multiple EC2 instances. It's like having a shared drive for distributed applications. EC2 also integrates seamlessly with S3, which is AWS's object storage. Many people use S3 to back up EBS snapshots or share data between instances. These flexible options make EC2 suitable for a wide range of workloads. AWS provides several ways to pay for EC2. On-demand is the simplest. You pay only while the instance runs. It's flexible but most expensive. Reserved instances gives discounts if you commit for 1 to 3 years. This is good for stable workloads like databases. Spot instances lets you use AWS's unused capacity for up to 90% off, but they can be reclaimed with short notice. Perfect for flexible fault tolerance workloads. Saving plans are like reserved instances but more flexible, applying savings across multiple compute services. For regulatory or licensing needs, AWS offers dedicated hosts or dedicated instances which reserve physical hardware for you. And finally, for learning or experimentation, AWS offers a free tier up to 750 hours of T2 micro or T3 micro per month for the first year. Security and networking. Very critical for EC2. Instances run inside a VPC, which is a private virtual network under your control. Elastic IPs are static IP addresses you can attach to instances, ensuring they are reachable even if restarted. Security groups like firewalls controlling inbound and outbound traffic, these work at the instance level. They are stateful, meaning if you allow incoming SSHs, the return traffic is automatically allowed. I'll be talking and explaining more on this in future videos. Network ACLs operate at the subnet level and are stateless. You have to define both inbound and outbound rules. Elastic load balancers distribute incoming traffic across multiple instances for scalability and availability. And finally, IAM rules let instances interact with AWS services securely without embedding credentials. Elasticity is one of EC2's superpowers. With auto-scaling groups, AWS can automatically add or remove instances depending on demand. Scaling distance can be based on metrics like CPU utilization or custom CloudWatch metrics. Elastic load balancers ensures that traffic is evenly distributed across instances and unhealthy instances are bypassed. This combination gives you high availability. Your application stays up even if a server fails. It also saves money by scaling down when demand is low, so you don't pay for idle capacity. EC2 can handle almost any workload. Many businesses use it for web and application hosting, replacing traditional on-premises servers. It can run enterprise application and databases like SAP, Oracle, or SQL Server. EC2 is popular for HPC workloads such as scientific simulations, financial modeling, and rendering. With GPU instances, EC2 powers AI and machine learning tasks, from training models to running real-time inference. Developers also use EC2 for test environments since you can spin up a server, test, and shut it down very quickly. And finally, EC2 is used in disaster recovery plans. Servers can be launched on demand if a primary data center goes down. Some best practices when using EC2 is never store AWS access key on an instance. Instead, assign IAM roles. Enable MFA to add security for administrators. Keep instances updated with the latest security patches. Use encryption for EBS volumes and snapshots to protect data. Monitor resource uses with CloudWatch and track activity with CloudTrail logs. Design with fault tolerance by spreading workloads across multiple availability zones. And also automate as much as possible using AWS Systems Manager or infrastructure as code tools like CloudFormation or Terraform. And to wrap up, EC2 is the backbone of AWS compute services. It provides flexibility in choosing the right instance types, storage option, and pricing model for any workload. Security is handled through IAM, VPCs, and network controls. Scalability and resilience are achieved with auto-scaling and load balancing, and whether it's a personal project, a startup app, or a global enterprise system, EC2 provides the foundation to run it reliably in the cloud. And that's all for this video. You can move on to the next video to learn more about EC2. Please like, comment, and subscribe before moving on though. That will help me greatly. And thank you.